Hi there, welcome to Something of Everything. In this video we will see how to design water tank in STAAD Pro. On public domain this video is being recorded. We will see a water tank of 6 meter by 8 meter by 5 meter height. Okay, the first task is to create the geometry for the same. Let us do it. Let us create the first node. In the geometry section, in the node table, we have written the coordinates for the first node. Just select that, copy and paste it. The length of the water tank is 8 meter. The two nodes are being created. Select these two nodes, copy and paste it. The height of the water tank is 5 meter. Now we have the first wall nodes, corner nodes for creating the first wall. This is generate surface meshing. Select that command and go clockwise from bottom. Quadrilateral meshing. Okay, we will be creating the plate elements of a size of 500 mm by 500 mm. So for 5 meter it's 10 division and for 8 meter it's 16 division. Okay, the first wall is created. Make sure that Z is outside. We have to make coordinates alike. Means Z needs to be outside in all the coordinates. Select this plate, copy it, paste it in the Z direction, that is width. The two walls are being created. We have to create walls in between. Make sure Z is in the outside. Here the Z is not outside, so we have to select it. Select these plates, go to commands, geometry constants, plate reference point, away from reference point to selection. Okay, the Z is outside. Okay, this way you can change the orientation of the plate. Now that the two plates are being created, we have to create the width side of plates. Select generate surface meshing, go clockwise, yes. Quadrilateral meshing, division of 500 mm by 500 mm. Check the Z. Z is inside, right? And here the X up, here also X up, but Z is a little bit complicated. Select these plates, go to commands, geometry constant, plate reference point towards 0 0 0. Why some of the plates are still in the Z in direction? It should not be like that. Select each plates, go to commands, geometry constants, reference points towards reference point. Okay, it's cold, it's been done. Again let us try it. Towards reference point selection. It should have been changed. I don't know why it is not changing. Let us select it and see what is happening. Which of the plates are not it's not being selected. Let's zoom it. Some of the plates are created some of them are not, right? This plate is what is causing the problem. Let's do it for it only. It's not changing, right? Why? You should have changed, but I don't know why it is not changing. Let us do it. We can change it, because if it's not going this way, it will go this way. That's not a problem, but it should have changed before only, because in such a case make sure you have to change it either way. If it's not changing by default, you have to change it manually, selecting one place, because it will help you in loading. Everything is okay in this plate. Commands geometric constant plate reference point. What its right point towards that point, local z axis of the selected plates is towards 0 0 0. This is 0 0 0, and all the plates are here. It should be like that, but it's away from 0 0 0 and it's changing, right? If we see the coordinate of this point as we have modeled it at 0 0 0, it is at 0 0 0. Sometimes happens because you cannot predict what the STAAD will do. You can predict more pretty, but not always. Commands given. Okay, now let us see if everything is okay. Yes, it's done. So now the next point is to copy it and paste it at the other end, but this time with a different way. We have selected a reference point, and the reference point was this one, I guess. Sorry, this one. Let's paste it, and the walls are created, but again we have to check the geometrical constraints. That is Shift T. You can check out the shortcuts of STAAD Pro at www.tinytopics.in, wherein I have given all the shortcuts of STAAD Pro. Just select this, go to commands, geometric constant, reference point, away from the reference point selection, and it's done. It's complete. Walls are created. Now the time is to create the base. Right? Select the point node, select points, enter PB, and the points are here. Go to surface meshing, select clockwise. No, this is auto save. We will learn about Baker in the next videos. Quadrilateral, where it is 8, it needs to be 16 division, and in the case of 6 meter it needs to be 12 division. Apply it, and the base is created. If you want to have projections outside the wall, just select this wall, copy it and paste it. So if this is also selected, I should not do it. Copy it. This is the reference point. Okay, this is the reference point. Okay, likewise copy, paste, reference point needs to be changed and pasted. Okay, now this copy, paste, Control C, Control V is being used for copy paste. That, and the bottom side Control C, Control V, reference point, this one and this, done I guess. Now you can see water tank is modeled. Top slab is not being modeled in the water tank. Okay, now there comes the thickness. It can be tapered, it can be flat. Let us first think it's flat. Go to thickness, flat element thickness, and let's give 350 volts and the same size of base slab. Okay, assigning the same to the whole geometry. Now comes the supporting. The base will be of subgrade modulus, foundation type, elastic mat Y, and there will be a subgrade modulus. If the SBC is 150, let's learn that. If SBC is equal to 150, the subgrade modulus will be 150 into 2.5, that is factor of safety, divided by settlement 50 mm. That comes out to be, I'll have to check calculator, sorry. That comes out to be, there is a calculator here in STAAD Pro itself. You can use that calculator. From 12 calculator. What was it? 150 into 2.5 divided by 50. Execute. This 7500. Elastic mat Y direction and the subgrade modulus is 7500. Okay. Edit. Give supports to the base. Okay, now that we will be transferring the horizontal force of the wall's top to the top slab, because it is pinned at the top, so we have to create a support at the top. Begin. Release everything except FX. Likewise, release everything except FZ. We will take tension only. Now, in the case of walls in Z direction, the support will be FX at the top. In the case of X direction walls, support will be of Z. Let's check it. This way you can create pins in the walls. Now the case is of walls. Let us say the FGL is at 1.5 meter up. So from outside there will be a soil pressure, from inside there will be a water pressure. We are assuming that the water tank is full up to 5 meter height. The water level will come. Generally the water level will not come up to the full height, but we are taking it in this case. Let's create a case. The first case is water load. The other case is soil from outside. The third case is surcharge. And the fourth case is dead load. Okay, we can create the top slab, but we are not creating it. In such a case, if top slab is not created at the top, you have to create the beams at the top where you are resting your slab, because you are not going to create a one slab of 6 meter by 8 meter. Let's break it. 1 2 3 4 5 6 7 8. This is the midpoint, I guess. So the length is that of 14 meter. We can check it out that this is 4 meter, right? That means the wall will come at, beam will come at this point. Geometry connect beams along z axis. One beam is created. Now your water tank is that of 4 by 6, but we want to still break it. This is 3 in z direction. That means the geometry x direction beam will come in this direction. You can see it. Remember, where a beam joins, the support will not come because it transfers the forces. First select the no support, then select the nose, and then assemble. It's gone. Okay, it's not gone here. It should have gone, but the other node has been selected. That's why. The size of the beam can be 45 by 300. Assign to view. Okay, done. Now that in order to give the loadings of floor, you have to create nominal beam in this direction. Let us say a runner beam kind of thing. Geometry configure beams along z axis. This direction. Selected geometry connect beams along x axis. So will be the nominal beam of size same as wall. Okay, done. Now the case is where we were at this point. Let us give the water flow. You remember we have done z outside in all the cases. Let us give the volume. Let's first select one plate. Shift T, Shift S, select plates. We are selecting one row of plate. Okay, this is one row of plate. Let us give water tank load. It can be given by hydrostatic load. Plate loads, hydrostatic. Select plates. Let's select one row, one column of plates. What will be the maximum pressure? 5 meter height water tank. K gamma H. For water, K is equal to 1, gamma is equal to 10, and H is equal to 5. That means 50 kilonewton per meter square load at the bottom. W1 will be the maximum load, that is 50, and W2 shall be 0. It will, pressure will be in the direction of Z, interpolation will be along Y. Let's give it. Let's check that out. Complete. Now that you know that this is right, just go on selecting the same. Let's see first, right? The whole first bunch, just select walls. You can select walls parallel to XY, select walls parallel to YZ, and alter VV, that is select specific. In such a case, this load will be made. These loads need to be in the whole base length. Selected plates. Okay. If you are giving it this way, you are reducing the file size, and the loading will come perfectly because you have given the same Z in all the walls. Okay, this is done. Likewise, you have to do for the rest. Select the plates, give it. Select it, select the plates, assign to selected plates, give. Assign to selected plates, give it. Assign to selected plates, give it. Likewise, you can give the soil pressure also, and yeah, we will be giving assigning. Okay, meanwhile and it's in just this 10 lines or something we have given the loading on the walls. Now the case is of soil load. Same way, plate loads, hydrostatic loads, select plates. Just select one row of plate, anyone can be there. W1 will be a gamma h square. Height shall be 1.5 meter from FGL. K shall be 0.3 into 18 into 1.5. We will have to take the calcium. The new generation doesn't work on the mouth calculations. That's PT, I can say. It's 8.1. Okay, this shall be minus 8.1 because Z is outside and we have to give the loadings from outside. Interpolation shall be from 7. Okay, you can see it. Let us see. There is one mistake in this, yes, it will be applied to the 3 plates, 3 bottom plates only. So control Z it if it can be control Z. Sorry, it can't be control Z. Okay, if it can be control Z, it can't be control Z. I guess yes, it can't be control Z. Let's delete this and then okay, we have deleted it. Just go on selecting only one plate at a time, just these 3 that you need, and that is only in one direction. Now select walls, plate loads, hydrostatics, select plates, give those plates a chance to be selected once again. Okay, bottom load is -1, 8.1, top load is 0, interpolation against Y. Let's say if it's true. Yes, that's true. Now we have to give these loadings to all the plates. Select it, assign it, select it, assign it, and select it, assign it. Okay, done. Now it's time to give the floor loading. Water shall be giving the pressure to the floor. That will be 50 kilonewton. Global y direction. Okay, let's select the. We know that. How can we select it? I guess if you don't know it, just wait for our video on. It's difficult, I guess. Do we have to select it manually? Yes, we have to select it manually. Enter VV, select this, enter VV. Okay, this much area shall be in the pressure. Okay, outside can be the pressure of soil. If you want to give the soil overburden pressure, that will be 1.5 into 80. Let's give it 1.5 into 80. 1.5 into 80. That is 27. 2.7. Sorry, it's not 27. It's 2.7. Okay, the soil pressure. Plate minus 27. Give it to periphery, it is outside the soil base. Okay, let's select this, assign it to the plates. I guess you are understanding it. Now the surcharge load. Let us take the surcharge load of 5 kN per meter square. Ka into Q. Ka shall be 0.33 and Q shall be 5. That is to become 0.3 into 5. 1.5. 1.5. Other pistol is 0.3 into 5. 10. Let us get it. Now it's pretty difficult to understand, but okay. Surcharge loading, plate loading, that will be the case of pressure only in the negative direction. That is 1.67 in the local Z direction, right? Okay, the pressure shall be in the local Z direction. You can see it. This will be the surcharge pressure. And I guess the loadings are completed, and the dead load shall be self-load of the structure that is needs to be assigned to the view. The next dead load shall be of floor load at the top. For that you have to group it alike. Select the beams, go to Control G and define the group as slab. Okay, beam, sorry, it's not a beam, you have to delete it. Slab, it's a floor type of grouping. Let's associate it. Now select plates parallel to XY, create walls in X. That's plate. There can be walls in X. Associate. Select plates parallel to YZ, create walls in Y. And select assign it. You can select base manually. Create base. Plate element assignment. Okay, grouping will be helpful in future. Now give the loading to the group floor load. The live load on the slip will be 3. Just giving it, not calculated it. Okay, this is live load, but I am giving it in the dead load because you don't want to reduce the live load. It can be given. And the dead load shall be of the slab thickness. That will be, let us assume 150 plus floor finish of 1.5, that is 3.75 plus 1.5, that is 5.25. Adding it to the floor. Okay, almost every loading is being given. Now we need the combinations. Which kind of combinations can be done? For example, let's just giving it head load plus, okay, plus water load. Let's assume the soil is not filled, plus soil plus surcharge. Okay, that means everything is given. The other case can be dead load plus soil load plus surcharge load, soil, surcharge and dead load. Add it. The other can be dead load plus water load only. Soil is not filled outside, such as is not in the picture. Let's just assume that these 3 loads will be taken care. Let's analyze this. We have forgot one thing. We have not given any command of perform analysis. We have to give it. Perform analysis, print, no print. Okay. Now just perform analysis. Let's see how many errors are there. I guess no errors. Great. Now we have to check for which condition we want to see. We want to see just for the dead and water loads. Okay. You have to take the forces out in order to design the same. Okay. Let us go to plate center stress summary. Go to summary. These are the forces. Maximum mx is 3. Maximum mx is 7. My is 2. What is mx and my? Mx is vertical moment and my is horizontal moment. Okay. Let's just see where it is coming. If you select any row in this, it will select the specific plate where it is coming. Now we want the moments of walls. Go to result setup in range, select the group wall in X, and you will get the forces in X direction. These are the forces of X directions and Y directions. The maximum vertical moment is at top, that is 4 kilonewton per meter. And why it is at top? Because it is joining by the beam and transferring the moment. Minimum is minus 0.4 at the center. That will be the outside moment. As I guess, as we are modeling subgrade, the behavior shall not be same as we think of fixed bottom and pin top. You can check the moments of Y direction walls 2. Just apply it. As you know, in Y direction the moment is at top. Okay. The beam shall transfer the moments. Okay. Let's assume beam is just transferring the vertical loads. In that case, we will have to release the beams. You can do it if you want to, but I guess it's your choice. Thank you for watching us. In this video, you have learned about modeling water tank, assigning loads to it, and checking the moments and pressure of the same. You can check everything from plate center stresses, from shear force, shear in the plates, to the moments and everything. These are the results that you got. Thank you. And yeah, don't forget to subscribe to us, keep watching, and yeah, subscribe to our website www.tinytopic.in for informal topics on STAAD Pro, civil engineering, etc. Thank you.